Hello, hello, hello. Thanks for sticking around. This is the late crew of people who are present at the very end, so thank you. My name is Niels Bantilan, and today I'm excited to share with you this project I've been working on for a while. This is more of a data science, machine learning centric talk, but it's all about making your data processing pipelines more readable and robust using Pandera. Before digging into the meat of things, a little background on myself. I'm currently now the chief ML engineer at Union AI. This is a startup that basically spun out of Lyft. They created this orchestration platform called Flight, but now we are trying to commercialize that and helping people to build out their AI ML infrastructure, as well as data processing infrastructure. So that's where I'm at now, but I've had kind of a long and windy path through biology, dance, and public health. So maybe a little bit of a non-traditional background, but I think that's more and more common these days. I'm one of the maintainers of Flight, the platform I mentioned earlier, the creator of Pandera and Union ML, which I'll be talking about tomorrow, actually. And my mission these days is to help make data science and ML practitioners more productive. In my spare time, I do like to dabble around with various machine learning like algorithms, reading papers and whatnot, but I gravitate a lot more towards the engineering aspects of this discipline because, I don't know, it seems like you can they're like achievable goals that you can reach as opposed to like nebulous performance metrics of a model. You know, who knows what loss you really want. So with that out of the way, I wanted to motivate this talk by asking this question. As a data scientist or ML engineer, how do I make my pipeline more robust to data errors? And to just give you a very simple example, right? If I have a question about the world, say, what's the COVID rate going to be next year? In order to answer that question, I'm going to have to read some data from the real world, clean it up for the purpose of my analysis, analyze the data, and then I'll end up with some kind of report, maybe with some graphs, some summary stats, and maybe even a model doing the forecast. Now, a lot can happen during just even this very simple pipeline. So all sorts of data corruption can occur in the real world, because the real world is a crazy place. So like intentional or unintentional data corruption can happen just, randomly. And you can also, mess up the implementation of your clean data step. And there are many more sources of data errors, but these two examples will lead to findings, conclusions, results that are just incorrect. And a lot of the things that I've learned in practice is, you won't find out, like data errors are mostly silent until, your graph shows up and there's like weird things happening that you didn't expect. So the crux of this talk is, adding these little green pills, I guess, in these boxes, right? I want to be able to check for known data corruption, and as I uncover them, I want to be able to add assumptions to this green artifact that I'll, obviously describe more in code a little later. But I also want to validate that my code implementation is correct. So I want to not only validate data coming in at the interface boundary of my pipeline, I want to make sure that at certain critical steps of my pipeline that things are as I expect them to be. And to maybe ground this, to make this a little more, scope this down a little bit, one of the de facto libraries that data scientists, ML folks, data engineers, data analysts, I don't know what the titles are these days, but you'll use pandas quite often, or pandas-like kind of interfaces, right? So I'm guessing, how many people here have worked with data frames? Okay, good amount of people. So you can think of data frames as basically Excel tables or tables in general that you can manipulate programmatically. So there's a quick example of where each row is a person identified by some ID, and we have some attributes about maybe the number of hours they worked and the wage per hour, say. I'll come back to this example later, but this gives us a sense of the data structure that we're working with just for the purpose of this talk. And so one of the things that I've found in practice, and there are a bunch of libraries that do this now, is asking this question of what's data validation at this conceptual level. And I like to define it as the act of falsifying data against explicit assumptions for some downstream task, some other purpose like analysis or modeling. So if I make the statement or hypothesis, all swans are white, one approach to verifying this claim is going out and finding all the swans and checking their color and making sure they're all white. But another way of doing this, right, and this kind of like the scientific method, is instead of trying to find all of them to validate your claim, you can find the first instance of a black or a purple or whatever different colored swan, and now I have to refine my statement. And this is the scientific process. You make a hypothesis, collect some data, might do an experiment, and depending on what you find, you're going to have to refine those statements, and at some point you end up with a theory that kind of applies very broadly. And this is, as a data scientist, ML data practitioner person, you're going to want to do like the microcosm of science every time you're working with data, every time you're processing it or modeling it. And one of the lessons I've learned is, everyone has a personal relationship with their data frame, right? You've worked with it in your Jupyter notebook or your REPL. You know the ins and outs of it. But in 3 months, you're not going to know anything. You're going to forget. Your colleagues don't know anything about what you've learned. So I'd like to take you through the story that I've experienced, something you might have experienced as well. So imagine that you're a data scientist maintaining an existing data processing pipeline. And one day you encounter some kind of error, and it says, there's a type error. I can't multiply sequence by non-int of type float. OK, so you're trying to do some operation, and it's not valid, but that's not very useful. You follow the error log, and you find yourself at the top of this process data function. You look around, and you can see, in the function body, you can kind of get hints of what's going on, right? I'm trying to compute weekly income by multiplying hours worked with wages per hour. Simple math. I'm starting to form my hypothesis of what's going on, but I want to take a closer look. So I put a little breakpoint in there. I do some just quick print statements of various things. So, it's the party going on back there. Yeah, so you print out the data frame. Things look OK. Things kind of look floaty, looks like a number. You look at the df.data types. You see hours worked is an object. OK, so that's weird. Then you print out the types of all the values in the hours work column. And you see then this row 4C977A9 that value is actually a string. Who has experienced something like this in their work? OK, awesome. So, you squash the bug. You make sure you do as type to make sure the types are correct. You maybe have decided that negative hours worked is invalid, so you decide you want to turn those into nans, and then you compute the weekly income from there. So the output of processed data is what you've agreed to as valid data, where this last row just doesn't have hours worked, so that's fine. A few months later, you come back and you find yourself at a familiar function, process data, but a colleague has changed it. You do a git blame, and you see someone else has changed this function signature. And this is Pandera code, by the way. You see there's this data frame generic type that has this raw data thing inside of it, and then the output annotation is a data frame with this process data thing. Okay, so and then you also notice that the as type method call is gone. Okay, weird. So you look above the function and you see these two artifacts now, these two class definitions, raw data and process data. And you can see that we're explicitly saying what the columns are, what the types are of each column, and that we want to coerce the types as the data passes through the function, and that all of these fields are nullable. And you also notice a little check types decorator here. And I'm going to dig into this a little later, but this is basically a little microcosm of sort of documenting your code, documenting your data in code, and enforcing it as well at runtime. So if you're familiar with Pydantic, this is something that's super useful. You do get a little runtime hit because you're doing some extra validation there, but it's well worth it if you're going to prevent silent bugs. So the moral of the story is, the better you can reason about the contents of a data frame, the faster you can debug. And the faster you can debug, the sooner you can focus on the tasks you care about. And by validating data through explicit contracts, you also create data documentation for yourself in the future or the rest of your team. So returning to this question, is data validation enough, though? And I want to say it is necessary, but there's this other term, floating around in the data sphere around data testing, which is essentially data validation of real data, as well as pipeline validation, the thing I hinted at earlier, where it's like I'm implementing the clean data function, and I want to make sure my implementation is correct. So this is basically what I just said. And by testing the functions, validating the functions that produce the data, I'm referring to the clean data set that I end up with. And actually, Pandera gives you the tools to generate synthetic data from this raw data schema, So yeah, here it's being used to validate the real data coming in, but it also serves as this generative schema that you can use for property-based testing. So I like to frame Pandera as a data testing and statistical typing library for data science and ML-oriented data containers. So currently that means Pandas data frames, also supports Modin and PySpark and Dask. But the plan is to sort of expand the scope of this so that we're validating other types of containers that are sort of like columnar or array based. I'll get to statistical typing later, actually. It's a kind of interesting way to frame this whole problem. So you've seen a lot of what the syntax looks like, but to just kind of hammer it home, the quick start of Pandera is you define a schema, and it very much looks like data classes or Pydantic models. So here I'm defining an input schema, year, month, day, and I'm stating certain constraints about it. So year, I'm only interested in data after the year 2000. And then I'm verifying month values and day values here. Now, you can inherit from input schema. And basically, you can define the transformation interface by saying my output basically has all the fields of my input schema in addition to revenue, which will be added to that data frame at some point in your pipeline. And there it is. You have your transform function. Adds revenue here. This is obviously a toy example. This is like just a single value for all of the rows, but you get the idea. So you can validate input and output data frames of your functions at runtime. So calling the transform function on valid data just passes that data through so that everything is well and good. But if you pass it invalid data, and the invalid data here is you have a year 1999 here, which is by definition incorrect, Pandera is going to throw an error. And it's actually going to pinpoint the failure case and the index at which that failure case happened. So imagine you have more failure cases, you're going to be able to pinpoint all the different error cases in your data frame. Just a quick question: who has tested their, made unit tests involving data frames and just had a lot of trouble handcrafting, manually? Okay, a few hands. Okay, so this was also a key pain point that is a itch that I wanted to scratch. So Pandera integrates with the hypothesis library to basically be able to call input schema.example, and it'll give you valid data under the constraints of your schema. Pandera integrates with a bunch of Python ecosystem tools, so all the data frameworks here, Pandas, Dask, Modin, PySpark, GeoPandas, and Fugue. There are other supported integrations here, Pydantic, FastAPI, Hypothesis, and it supports currently 2 orchestrators, Flight and Dagster. So the next thing I wanted to address here is statistical types. And this is the thing that I kind of coined it, but I don't think it's anything really new. It's just kind of a reframing of how to think about these things. So essentially, if you consider a single data point, right, you might have data about a person, their name, height, weight, occupation. And so what can we say about this data? We can state certain atomic properties about it, right? So data types, value ranges, allowable values, things like that. But if you consider a collection of data points, there are properties about that collection that are now unlocked because you have a collection, right? So uniqueness you can't assess with just a single data point, or monotonicity, or the descriptive statistics of your choice. So these are things that you can actually assess with collections of data now. And so essentially, statistical types extend primitive data types to include semantics about collections of your unit of analysis. So you have your primitive data types. You might state some deterministic properties about the possible values of those data points, and then probabilistic properties. So you can see hypothesis tests as being included in this framework, and you can actually do that with Pandera. I wanted to show you 2 examples. I'll run through them a little bit quickly, but happy to chat through sort of how you would use this in the real world. But we'll look at a data analysis example. So this is the California housing data set. It has about 20,000 samples, and the unit of analysis is the California district, right? So it has different attributes that are aggregates, like average bedrooms, population of each district. So this is the simple analysis pipeline that I showed a little earlier, just slightly modified. And here, we're going to create a housing data schema. I mean, obviously, this ships with sklearn, so it's probably the quality of it is pretty good. But imagine if you were using some other data source. So here's the schema for this data set. And right now, you'd have to go to the docs of sklearn to read through what the attributes are. But this actually, this documents it and also validates it at runtime every time you load your data into memory. So with this check types decorator and the housing data frame output annotation, as I said, every time you call read data, it's going to make sure that the types are as you expect them to be. Now, say you hypothesize that median income is positively correlated with median house value, right? You can plot that, you can generate the statistic about it, and that you could call it a day. But then you can also use this extension API of Pandera to add, So to add additional, oh, I'm not pressing any buttons, but the slides are changing. Is someone summing the keyboard there? OK. Seems to have stopped. So you can add custom checks to Pandera. And so this is basically, not sure if you can see this, but this is basically doing a correlation test. And you give it an alpha value, so it's significance testing for this hypothesis. And you can add it to your analyze data function. So you can basically create this Pandera schema on the fly within this function body to actually do the hypothesis test every time you analyze the data. So say you swap out the data changes, you're going to always do this hypothesis test whenever this function is called. So that was an example of hypothesis testing for the purpose of data analysis. Here's a quick example of a machine learning pipeline. Right? So if you've ever trained these kinds of models, you split your data into a training and test set. You train the model on your training set, and then you evaluate your model on both training and test splits. So you can identify the critical data error sources of data error in your pipeline and check those parts. Right? You don't have to check every single node in your execution graph. But this is an example of basically using the exact same schema that we defined in our analysis. We're reusing it here. We can reuse it in our tests. And just to hammer home the fact that you don't always have to do runtime checks. So notice I don't add the check types decorator here. So now this is simply serving as a kind of a type hint for MyPy to take a look at. And then, for the training and the evaluate steps, I'm not even doing the Pandera schema annotations here, just because, the way I'm using these functions, it's always going to be in concert with the previous steps that have validated the data. So if we return to this training pipeline, the way the code might look like is this. You might return the model, the R² values for the training and test splits, right? But you can also use Pandera in your unit test suites, right? So if you don't want the performance hit in your production pipeline, you could still use Pandera in your unit tests. And this is where Hypothesis comes in, which is an awesome library. And basically what I'm doing here is given a housing data set of size 20, I want to test my entire kind of end-to-end pipeline. And so this generated data is passed into my test function, and now this is valid data according to whatever my schema specification is, and now I can run an end-to-end test of my ML pipeline, which is in my experience, not a lot of people test their ML code, which is interesting because all sorts of bugs can occur there, and this is sort of also one of my motivations for creating this library. And this is a depiction of basically using that raw data schema to feed into the rest of my pipeline to test it. So just to summarize, you can basically use Pandera, and you don't have to. It's designed for incremental adoption, so you don't have to buy into an entirely new way of validating data. It's all kind of pretty standard Python. And it really lets you encode the domain knowledge that you build as you analyze, as you explore data. It lets you encode that into class definitions, these schema definitions. And I didn't get into this, but if you're in a hurry, you can use this infer schema function, and it'll kind of create a draft schema for you, and then you can play around with it and refine it. So this is very basic data profiling. So yeah, again, you don't have to validate everything. You just identify the key kind of critical points where data errors can sneak into your pipeline, and then validate those parts. if you have domain-specific checks that you have that doesn't ship with a Pandera library or no one's built checks for, you can define them very easily with custom validation rules. And then, as I showed you, you could reuse schemas at runtime in your test suite. You can modify them. You can inherit them and change the schemas around. And the result is you can just have more of a zen and just like be more confident in the quality of your data. And things will still break, but when they do, okay, now I need to update, as I said earlier, like the scientific method. You update your understanding as your schemas reflect them. So the quick roadmap for this project, I've been maintaining it myself for 3-4 years with a really awesome community of contributors. So we're planning to make it more extensible, improve the user experience, and improve the interoperability with other Python libraries. And on that front, I am excited to announce that I'm basically joining Pandera with Union AI. So it's joining the open source ecosystem of Union AI, including Flight and Union ML, which means that we'll just have more resources to maintain it, build it up. And if you're interested in getting involved, there's the GitHub repo. We have a Discord channel, and you can take a look at our documentation to learn and help us improve it. We're also hiring, shameless plug. And yeah, thank you for your attention, and I hope you learned something about making pipelines more robust and readable.
Thank you, Niles. That was great. I really like the idea of creating schema for your data. One of the things I love about DevOps and the automated DevOps is that deploying and installing stuff is hard. So we codify the arcane knowledge into charms for Juju, and Ansible has its own recipes or whatever. Okay, and so here we get to working with our data, an aspect of data engineering. Define the shape of your data. I really like that. Do we have any questions?
Thank you. That was super cool. You mentioned Pandera.infer schema. Does that generate a runtime model, or is generating code that you can copy paste into the file?
Yeah. So it's the intended use is the first one. So you're meant to, when in the development process, when you start working with data, you're meant to use that as kind of like to bootstrap a schema, so you don't have to write it out by hand. So if you have a large table of 50 columns, you're gonna have to write all of that stuff, right? Also, by the way, you can define regex fields. So you can define regexes that will apply the same validation rules across a bunch of columns. So as an aside, but yeah, you're not. I think I forget the behavior now. I think it raises a warning or even an error if you try to validate data using a schema directly from infer schema. So if you infer a schema from data and then you use it, that's kind of like a weird kind of interaction. That's kind of, I don't know. It's tautological. It's kind of like I'm getting data in, I'm inferring the schema, and then using that inferred schema without actually looking at it. So you use infer schema, you get a schema out, and then you can say schema dot toScript, and it'll like dump it out into a string, and then you can mess around with it.
Amazing, thank you.
Yeah.
Thank you. Is this on?
Go ahead, David. Do you need a different mic? Is that one working?
Maybe. Or am I? Okay.
Oh, yeah, there you go.
We can hear you.
I'm actually going to ask you the same question I asked you last night. And since you've had a whole 18 hours, I assume you've implemented it. In the California data set, you're using it as an example there in the slides, which is a lovely set. There's one house, you actually showed it in the display of the Panda statistics, that has 116 rooms, which is in fact about 6.5 z-score, standard deviations from the mean of that data set.
Yeah.
I don't like that house. I think that's an outlier.
Yeah.
So in order to exclude that, you actually showed an example of putting fixed boundaries over, I think, 100 in your example.
Yeah.
So that would be excluded on that basis, but that's not data sensitive. It would be nice if we could express that as a predicate about the column. Any thoughts on that?
Yeah, I would love to support predicates in Pandera. Yeah, I mean, there's no issue for it yet, but I have talked to it about it with other people who are interested in that feature. Yeah, I think that would be super cool.
It's open source now. I guess I'll add it.
We have another question over on the left.
Hello, thank you for this interesting talk. I just wanted to ask, a particular thing has caught my attention, which is the thing about the validation of ML pipelines, and specifically the example, so the second example you've shown.
Yeah.
I wanted to ask just in more particular kind of way, does it support, for example, comparing or trying or testing, is it only development pipelines, or does it support also production pipelines? To explain that, I would cite, for example,
Sorry, can you?
Sorry.
Yeah.
So basically, just testing, for example, in production, data drift, or testing if there is any significant difference between the train and test split during the machine learning training and evaluation.
Yeah, so there are libraries now that kind of specialize in this. Deep checks, I think, is one of them. Evidently AI. So Pandera doesn't. You can certainly do that with Pandera. You kind of have to. It's more of like the kind of. I don't want to say primitives, but it's like the building blocks for getting those things done. I can certainly see a future where there are kind of things built on top of Pandera to enable those things in like one line of code. But right now, it's not supported, so you kind of have to handwrite those kinds of checks yourself. Yeah.
Okay, so those checks are more oriented towards assuring the robustness of the development pipeline, right?
It's both development and production. It's just more focused on the data frames themselves, and you can check predictions as well, but even model weights, right? If you can fit it in a data frame somehow. But definitely the focus is more on the data structure itself, and not sort of like second order things like comparing models or comparing different splits. Yeah.
Thank you so much.
Okay, thank you very much, Niels.